Hello. Today I'm going to go over multiple Angular attribute directives. I'm also going to first get into parsing formatting flow for Angular and introduce one issue with parsing formatting that can happen, and then get into um, multiple Angular attribute directives. So first things first, here is my example application. We have a city government app and a flat tax, and essentially the flat tax is a member in the domain model data, and here it is being formatted, right? There's a $sign next to it, and if we look at our code, we can see the structuring of how this is brought about. So I have here my controller, which is where I'm holding the domain data. Here's the flat text domain data member, and here is the input DOM element where I am injecting, if you will, the flat text member into the ngModel attribute. And there's another directive, cache format, which talks to the ngModel attribute. Now what we're going to get to in the second half of the presentation is having a second attribute directive that in tandem works with this directive here, and they both work with the ngModel directive. So it's actually three attribute directives on the same element that we'll be looking at. And before we look at the cache format directive code, I'll do a little bit of prefacing of the formatter's parser's flow with Angular. So Angular has 4 holders of data in the formatter's parser's flow, which is, to reiterate if I didn't already, taking the domain data, which is this guy, and formatting it to be presented in the view. For us, that's the $sign here. The parser flow is taking a change, like adding a 0, and how this data is parsed and updated back to the domain data. So in our case, with the 50, the new value here would be 50. So given that flow, there's 4 different areas where there's data that's important that Angular and the browser HTML environment take care of. The first is the actual domain data, which I just pointed out in the code. The second is one that is a member of the ngModel attribute. It is called model value. It is a copy of the actual domain data. The third is the actual view data. So for us, that would be like the data that is a part of the input DOM element. And then Angular on the ngModel attribute, there's another member called view value. And they're actually a part of the ngModel attributes controller, to be more correct. And that is a copy of the actual view data. Now, there's two main processes. The formatting flow, which is if one changes, format change data and update 3. The other main process is the parsing flow. If it's kind of like the reverse, if 3 changes, parse change data and update 1 slash domain data. So that is a quick overview of what the Angular formatters parsers are doing. And they're called formatters parsers mainly because the mechanism for achieving these flows are two arrays, a formatters array and a parsers array. And what this allows for is having more than one directive, or one directive add multiple formatters and multiple parsers. So you that's what's achieving this flow, if you will, or achieving formatters and parsers. So as you can see here, that's what we're pushing onto in the cache format directive. And we're doing the same for parsers here. We're adding this processing function, which takes data that's changed in the view, that's changed in our input, and parses it, which in our case is removing the $. That's what this is doing right here, or removing a letter that was just added, because that would be an incorrect number, and parsing the data so that it can be updated to the domain data in the correct parsed format. So that's that. Give me 1 second, just gotta look at my presentation outline. Okay, so like I was saying, there is this parsing that is going to clean the data, and it'll remove letters. So we can see that in action here. I'm going to type right now, and I'm going to type D, but nothing happens. Pretty good. And if we check our data, our domain data, it's 50, even though I type D. Now here comes a big hiccup, a bit of a bad headache if you don't know what's going on. I'm going to type D again, and it appears. Well, it's a big issue, right? It's the parser is supposed to take care of that, or at least it seems like we have code that is doing that, right? I mean, shouldn't when I typed the 50 and typed in a D, which you don't see on screen, shouldn't this function be called, which strips away the D, and we saw that first time around when we typed D? Well, the first time around it does that. The second time around we type the D and the D stays. So this function, which seemingly worked at first, it isn't working. And there's one main article that I found online that explained what's going on, and I'm going to do a dry run of what is actually going on to explain it, and then we'll update this code here and to be more correct and more standardized, and get rid of the bug we're seeing. So we have our gosh, you know, I'm going to explain the dry. I'm going to do the dry run soon, but there's one part I didn't explain. The view value is a way for Angular to look at what the view is. So when there's a change, Angular actually has an on-change listener on the input, and it compares it with view value. If there is a change, then it executes parsing flow. And it's the same with domain data. If domain data and model value are different, then we have an updating the model value and a call into formatting flow. Okay, so now for the dry run. So we have our model value, our view value, and elim val, the actual inputs value. And we're going to say over here enter or let's say, or 1 second. Initially, model value is 5. View value is 5. Elim val is 5. Now, let's say we enter x. Before parsing, here's what goes on. The elim val is 5x. View value is also 5x. Model value is 5. After parsing, okay, let's check it out. So view value is $5x. We strip off the $sign in the x, and that's what's returned and what updates the model value. So $5x, which is view value, becomes, or bare num is processed given view value being stripped of the non-number characters. So bare num is just 5, and that's what's returned. So after parsing, model value is 5. After parsing, elim val is new view value, which, as we can see, is bare num plus $sign. But wait, we're not updating view value. So we can already see that there's a synchronization error between the actual view and the copy that Angular has called view value. Now we do enter x again. Before parsing, view value hasn't changed. Model value hasn't changed. The actual view value is added with an x at the end. And there's actually no parsing. So why is this the case? Because there's a change to elim val. Angular has a onChange event listener it sees that $5x is the new view value. It compares it with its own view value, and there's no difference. They're logically equal, so there's no calling of the parser's flow. So everything stays the same. One second. You know what? I won't even write this. So you can see here now how that behavior of typing a letter and then the same letter again leads to the bug that we were seeing, which I'll show again just because it's been a little bit since I did it. X. We don't see it just as we expect. Bug happens. X shows even though we're trying to not have letters show in our formatted cache data. So, what's interesting too is if we enter X again, it's kind of baffling to see, but what happens is I'm going to hit X again. It goes away, and we can, for completeness, just document the dry run of what's going on. Before parsing 5. 5xx, and Angular sees there's a difference between the new actual view value and existing view value. So the view value that is presented to the parsing function is $5xx. The parsing function actually executes. Model value stays the same because it strips off. We strip off everything but the number, and view value is not changed, so it is actually 5xx. And ngModel is I don't want to look at that part because okay. So ngModel takes the 5xx, or the parser function takes 5xx, creates that bare num, and that's what drives model value, which is 5. And in our parsing function, we do ngModel bare num plus $. So that is $5. So we gotta keep going here just to show how there's a cycle of the bugginess that happens. So let's say we enter another X. Before parsing, after parsing, it is $x, right? That's different than 5xx. And model value is still 5. So what is this the exact replica of? It's this guy right here, this row. So it's just going to keep cycling like this. So I'm going to now introduce the the fix, which I researched, and this actually is from another article where somebody broke down what was happening with the bug. I'll give a link to that too in the description of my presentation. But let's get that nice good piece of code in here now. Oh. 1 second. All right, so we are doing things the Angular way here, which is to make sure that we use the Angular method for setting view value and not our own. So this is us going outside of the Angular world to drive the view value. This is us doing things the Angular way and not having any bugginess because we're following the Angular way of doing things. So we use set view value to have Angular take over, and we we set view value and we call for render, which is this function here, and that's where we have the actual input element be updated from our view value that we set right here. And what this leads to is a second calling set view value, actually calls parsers again. And in that second call, we can make sure that we don't have an infinite loop occur by checking if new value and view value are different. If they're the same, this won't be called, and we'll stop the cyclic calling at just 2 calls. So it's a little bit it's a big amount to take in, and it's best to do another dry run. Keep dry running. Now we'll dry run and show how this works. And first I'll show how this removes the bug by showing the app not have the bug occur. So I'm typing X. I'm typing X. Doesn't show. Our domain data, if you look in the console, is correct. We're just kind of being good QA workers right now. So let's look at that dry run. So, I'm going to say with fix, enter X. And we're going to think in terms of before parsing, after parsing call 1, and after parsing call 2. So we type in the X, right? So elim val is 5x. View value is 5x. Model value is 5. After parsing 1, let's look at the code. Model value is $5x stripped of the $sign in the X, so that's just 5. View value is new view value, which is bare num, which is 5, plus the $sign. So we do a set view value, and that also leads to elim val being $5. So let's write that down. 5, 5, and 5. Now there's a second call of parsing because we called the set view value function here. So we call it again. In our case here, view value is $5. New or bare num is 5, and new view value is $sign plus bare num, $5. And as you can see, new view value is equal to view value, so this conditional is not met, and we skip over it and just return bare num, which is what updates model value. So we're stopping the cyclic calling of the parsers here at 2 repeat calls only. And there we have it. We avoid that bug where if you keep on typing in the same letter, the letter will show itself every other type. As you can see, if we enter X again here, it's just going to be the same flow and the correct state at the end of the processing. Okay. 1 second. So now we're going to look at a new piece of our app, and there's going to be an issue with the code a bit, and here we go. Let's look at it. We're adding a yearly budget function or feature to the app. Here is our new directive that handles our yearly budget input. Right here. Just gonna give a little bit of time for the viewer to be able to soak it in. I don't want to move too quickly. And now we can see the that in action. When we check our data, we'll add this so we can see it on the console. And the yearly budget format is this. So we have a total property and month's data, which is an array of 12 items where, you know, very sensibly it's $10 per month because the total's 120 divided by 12 months. So $10 a month. And this is, let's say, domain-friendly formatted data. Having the data like this lends itself to being processed very easily and further domain processing for future features in our application. Like if there were other monthly costs, you would be able to just, you know, zip through the month's data or zip through 0 through 11 and access the indexes of your month's data and, you know, get a total cost very easily. So we can see here how the year processor directive is taking the domain data and formatting it. So it's just taking the total data member, which is right here. It's just taking it and adding a $sign and parsing if there's a change to the yearly budget. Then we are doing a similar thing like with the cache format directive, right? We're stripping of letters, non-number characters, and we're doing a bit of an extra step by parsing the bare num and doing some math for figuring out what the new monthly amount is and returning our domain-friendly data to the domain model. I just looked at what I did here, and I want to add in my fix first. Okay, cool. So let's see this in action. Now there is something wrong with it, but let's see it work in the first place. We'll do 1200, check our data, 1200, check our data, and darn. I wanted to show the month's data changing, so why don't I just log yearly budget month 1. Yearly budget month 1 is 10. We do 1,200 for the yearly budget. Yearly budget month 1 is 100, and all the other months are 100 as well. Okay, so it works, but there's one big mistake going on, which is we're not following the single source of truth rule, and we're not having dry code or don't repeat yourself code, right? Because we're doing the cache formatting in the year processor. So if we want to change our algorithm for how cache formatting does its thing, like maybe do an update to add formatting of decimals and cents to the cache formatting, well, we got to change it here and here. That having to change something in two places or having multiple sources of truth in programming is a no-no. So we need to use our programming powers to resolve this issue. And the answer is to have cache format and year processor be directives that work in tandem with ngModel to bring about a single source of truth for how cache formatting is done. So we're going to work towards having cache format be a third attribute directive on the input element. And here we go, diving into creating or following the single source of truth rule. So just give me one moment. So here's what I was thinking to resolve the issue. Our goal will be to have a parsing flow that has cache parsing flows. So it's going to be the input value changes, the cache formatter will parse the data, and then that data will be passed to the parser for the year processor. And with formatter, it'll be the reverse. With formatter, the first formatter we want to have called is year processor's formatter, which will basically take off the total from yearly budget, pass it further down the formatter's flow, and then cache format's formatter will add the $, right? So let's write that down. Cache format parses input value, basically removes $. Second parser function takes parsed value recalcs months data and update domain data. With the formatting flow, your processor pushes just total member further down flow. So it's just the year processor formatting will just strip off the total and return that and have that be what is processed by the next formatting function, which is cache formats. And cache format takes total member and adds formatting, or basically the $sign. So the only issue from here on out is being able to navigate through how Angular does its processing of parsing and formatting, and there's a lot of rules to it, and I will just dive into it. But as we go through the process, I want to say that the rules make it so that the end code itself can be easy to use. And essentially, the first there's two aspects two rules that will help us achieve this in our code. And that is here, 1 second. Parsers. Formatters. So the parsers order of call of calling the parser's data is in array order, called in array order. Formatters is the opposite. Called in reverse array order. And this is the first piece of the puzzle for achieving the pipeline that I described. The next bit is how do we control which directives link functions are called first. So how do we have cache format perhaps be called first, or your processor be called first? And the key to that is priority. So the higher the priority, the sooner the directive is called. But for link functions, it's in reverse priority order. So quite confusing. And I'll even add here. So compile and pre-link functions are called in priority order. And I don't want to get into compile and pre-link functions, but I will link to an article that explains it all. So this has higher priority than cache format because default is 0 in cache format. Thus, cache format's priority is 0 since it's not explicitly declared. So we go with the default. And what this means is that if your processor and cache format are on the same directive like we have here, then the compile and pre-link functions will be called first for your processor. But the link function will be called last for your processor since it has a higher priority, because link functions are called in reverse priority order. So what we're going to do is make note of I'm going to kind of dry code the link functions to show how the call orders happen, and we'll go from there. So the first call is our cache format link function. Second call. Your processor link function. So each of these functions will define the parser's function that gets pushed onto the parser's array, and same for formatters. So parsers Um, and if we think back to what we want our cache format directive attribute directive to do, parsing is remove $sign from view value. Formatters is recalc, or no, that's excuse me. Formatters for cache format is add $sign to val that updates view. Parsers is for your processor is recalc months data update domain. Formatters is just pass along total member. If you remember, we have our total member here, so if we are doing the formatting for your processor, which we want to have happen first, we just push just total member further down flow. And now you can see how this all comes together, right? I'm going to use letters here, A, B, C, D. So this is called first, right? So parsers gets a formatters gets B. Second call. Your processor pushes on C function to parsers. Formatters gets D. And so when we load the page, formatters is called because we want to update the view with what the domain data is. And formatters is called in reverse array order, right? So we go this way. So D is called first, pass along total member. Then B is called, add $sign to val. That is exactly what I described up here, right? Pass along total member, add $sign. That's great. Now, if the user changes the input, parsers is called. Parsers is called in array order, so this way. So A is called first. We remove $sign from view val. and then we call C recalculate months data update domain, which is exactly what we wanted when I went over the desired flow, right? Remove the $, recalculate months data, update domain data. So that's the explanation of how to code up the link functions, and we can, it's easy enough. I'll be able to just type that all up right now. Cache format looks good. We don't have to change anything there. With the formatter for year processor, pass along total member. Okay. We're not going to add the $. We're just going to pass along the total member. And that's taking care of the formatters. Parsers, recalculate months data, update domain. So as you can see, the C function is called at the end of parsers. It is getting a cleaned value that has the $sign removed. So that's how we'll treat it here. So parsers is, we don't need to worry about setting view value at all. We take view value, which is the cleaned input value that cache format gave us, and we recalculate months data, and we return total is just going to be view value. And this should work. Let's go ahead and test it out. Did the 1200. Now let's check. Yearly budget month 1, 100. And that is showing that months data is being recalculated upon the change here, and our whole flow of multiple functions in our parsers and formatters is this new structure is working correctly. So very good. And to conclude and summarize, the second issue that we saw, which was multiple sources of truth between our year processor directive and our cache format directive, was resolved by using this new architecture and assisted by attribute priorities and these seemingly complex rules for how formatters and parsers are processed. Parsers called in array order, formatters called in reverse array order, but these Angular rules all coming together to make it so that this business use case for having data flow back and forth between the view and the domain can be facilitated easily, which is being able to do it all in the link function, And again, this to reiterate, this helps out with having the data go back and forth from the view to the domain data in such a way so that there's extra processing that makes the domain data domain friendly, which is great. Also, we're allowing for cache format to be used on its own, right? It doesn't need to be used always in tandem with your processor. It can be used on its own, and I'll even show that part too, right? So we changed some stuff, or you know what? I don't think I changed cache format, but just to illustrate, cache format still works. Like, I can type in the 0 and it's now 50. I can type in letters and the expected behavior of not allowing letters to show works. It still is 50 in the domain when I check the console, and we're good. Alright, cool. That is all.